Good morning to all. Welcome back to Sigma e-learning Smart Audio Excellence. The topic we'll discuss today is probability previous year questions. In previous class, we have learned the concept of probability and various formulas related to the probability. In this class, we will discuss the various concepts as well as previous year questions from the concept of probability from the different board exams as well as from competitive exams. Question number 1. 25 names of girls and 15 names of boys placed in the box. One name drawn randomly. What is the probability of getting boys names and the probability of getting girls name? Let's imagine I have a box. In that box, I placed 25 names of girls as well as 15 names of boys. I need to pick a paper. How many times I can able to pick a paper? If I draw only one paper at a time, I have total 40 papers, so I can able to pick 40 times. So 40 times is the maximum possibility I can able to pick the paper. So my sample space will become 40. Why? Because I have 15 names of boys, 25 names of girls in that box. So by picking out one paper at a time, I can able to pick 40 times. So my sample space equal to 15 plus 25, which is nothing but 40. Sample space is nothing but the maximum possible outcomes. Here I have 40 names in my box. If I pick one name at a time, I can able to pick 40 times. So this is my maximum possibility to pick out a paper or to pick out a name from the box. So that's my sample space, or maximum possible outcomes are 40. While solving the any probability problem, we need to keep in the mind the probability of event equal to number of favorable outcomes by total possible outcomes. We know that all the possible outcomes are 40 in this problem, and we have to find the favorable outcome of girls as well as favorable outcome of the boys. After getting the favorable outcome of boys as well as favorable outcome of girls, we have to substitute these values in the formula. Then we will get the probability of getting the boy's name, the probability of getting the girl's name. Here we got the total possibilities are 40. We need to know the favorable outcome for the boys, the favorable outcome for the girls. As per the given data, we know that we have 25 names of girls in that box. If I pick out one girl name from that box, how many times I can able to pick out the girl's name? 25 times. Why? Because I have only 25 names of girls in that box. So by picking out one paper at a time, I can able to pick out 25 times the girl's name. So the event of getting girl's name is 25. Here the event is simply the favorable outcome from the girls. So I have 25 names of girls, so I can able to pick out 25 times. So my event for the getting the girl's name is 25. As well as we need to find the event of getting the boy's name. In the same manner, I have 15 names of boys in that box. If I take out one name of the boy from the box at a time, how many times I can able to take out? 15 times. Why? Because I have only 15 names of boys in that box. So my event for the getting the boy's name is 15. So I know the sample space as well as event of the getting the girl's name, the event of getting the boy's name. By substituting these values, I can usually get the probability of getting the boy's name as well as probability of getting the girl's name. Here the probability of getting the boy is equal to the event of the boys by sample space. So 15 by 40, 5 3s are 5 8s are. I'll get the 3 by 8. The same manner, the probability of getting the girl's name is the event of girls by the sample space. We know the event of girls is 25, the sample space is 40. So 5 5s are 5 8s are. I'll get the 5 by 8. In this manner, we have to solve the probability problems. Always remember that the probability of any event equal to the favorable outcome by total possible outcomes. Problem 2. A shop consists of 100 shirts, of which 88 are good, 8 have minor defects and 4 have major defects. Jimmy will accept only the good shirt, but Sujata will reject only the shirts which have major defects. One shirt is drawn at a random from the shop. What is the probability that it is accepted to the Jimmy, it is accepted to the Sujata? A trader named Jimmy accepts only the good shirts, but Sujata reject only the shirts which are major defects, which means that here, as per the data given, Sujata reject only the shirts of major defects, which means that Sujata can accept minor defect shirts as well as good shirts. If I have 100 shirts, I'll pick out one shirt at a time. How many times I can able to pick out? 100 times. So this is my maximum possibility to pick out one shirt from the 100 shirts. So my total possibilities are 100. Why? Because I have 100 sets, which including 88 good sheds, 8 sheds of minor defect, 4 sheds of major defects. Total 100 sheds I have. I can able to pick out 100 times if I pick out only one shed at a time. So my total possibilities are 100 here. As per the data, Jimmy accepts only the good shed. So Jimmy can accept maximum 88 shed. Why? Because 88 sheds only the good sheds here. The same manner, as per the data given in the question, Sujata accept good sheds as well as the sheds with the minor defects. So Sujata can accept 88 good sheds as well as 8 sheds with the minor defects. So Sujata can accept overall 96 sheds can be accepted by the Sujata. So we got the total possibilities, the event of the Jimmy as well as the event of the Sujata. So we need to substitute in the formula of the probability. Jimmy can accept 88 sheds. So my event of Jimmy equal to 88 and total possibilities are 100. By substituting in the formula, we will get 0.88, which means the probability of acceptance by the Jimmy equal to 0.88 as well as probability of accepting by the Sujata. So Sujata can accept 96 sheds, which are included 88 good sheds as well as 8 sheds of minor defects. So total Sujata can accept 96 sheds. So my event of Sujata is 96. By substituting, we will get 96 by 100. 96 is the event of Sujata and 100 is the total possibilities. By simplifying, we will get 0.96. See, coming to the third problem. A box contains 5 red marbles, 8 white marbles, 4 green marbles. One marble is taken out from the box at random. What is the probability that marble taken out will be the red, white and not the green? Total 17 marbles I have. By picking out one marble at a time, how many times I can able to pick out? Total 17 times. Why? Because I have total 17 marbles. I can able to pick out only one marble at a time. So I can able to pick out maximum 17 times. So my total marble count is 17 and my total possibility is also 17. So we need to find the probability of getting the red marble as well as probability of getting white marble as well as probability of getting not a green marble. So first we need to find the probability of getting the red marble. To find the probability of getting a red marble, we need to find the event of the red. Okay. So total how many red marbles I have? Total 5 red marbles I have. By picking out one marble at a time, how many times I can able to pick out? Total 5 times. Why? Because I have maximum 5 red marbles. So my event of the red marble is 5. So total possibilities are 17. So the probability of red marble equal to event of the red marble by total possibilities, which is nothing but 5 by 17. So problem 1 is clear. Then coming to the probability of getting the white marble. So total how many white marbles I have? Total 8 white marbles I have. By picking out one white marble, how many times I can able to pick out? 8 times. So that is my event of the white marbles. So the probability of getting the white marble equal to event of white by total possibilities. So which is nothing but 8 by 17. Okay. So question 2 clear now. Question number 3. So we need to find the probability of not getting the green. Please listen carefully. We need to find out probability of getting not the green marble. So not the green marble means it can be red or it can be white also. Total 3 colors we have: red, white and green. We need to find the probability of getting not the green. Not the green means it can be red as well as it can be white. So we need to find the probability of getting red marble or white marble. So probability of getting the not green, which is nothing but either red marble or white marble. So total red marbles and white marbles together I have 13 marbles. So this is my event of getting red marble or white marble. Total 13 I have. So total possibility is 17. By substituting, we will get the 13 by 17. The probability of getting the not green marble is nothing but 13 by 17, as well as probability of getting either red marble or white marble 13 by 17. I have a spinning machine. See, this is the spinning machine. So this is the arrow. This arrow is freely rotating whenever we touch the arrow. Whenever we touch this, it will continuously run. After some time, it will stop any one number in the spinning mission. So we need to find out the probability of stopping at number 8, the probability of stopping at odd numbers, probability of stopping at number greater than 2, and the probability of stopping number less than 9. So if I touch this arrow, it can be stop here, 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 it can be stop here. In this manner, it can stop on any number from 1 to 8. So how many possibilities I have? It can stop at 8 places. So the maximum possibilities I have 8. Whenever I touch this arrow, it can be stopped at 1, 2, 3, 4, 5, 6, 7, 8. At any number, it can be stopped. So I have 8 possibilities of stopping. So my total possibilities are 8. Okay. Then we need to find the event of 8, event of odd number, event of number greater than 2, event of number less than 9. So first of all, we need to find the event of 8. So how many numbers 8 here? I have only one number which is 8. So my event is here 1. So why? Because I have one number which is 8. So my event of 8 equal to 1. We need to find the event of odd number. Event of odd number. So how many odd numbers I have? 1, 2, 3, 4. So total I have 4 odd numbers. 1, 3, 5, 7 are my odd numbers. So how many events of odd numbers I have? 1, 3, 5, 7. Total 4 odd numbers. Then coming to a number greater than 2. See, observe this figure. How many numbers are there which is greater than 2? So this is greater than 2, this is greater than 2, this is greater than 2, this all are greater than 2. Total 6 numbers which is greater than 2. The numbers 3, 4, 5, 6, 7, 8 are greater than 2. So the event of getting number greater than 2 equal to 6. How many numbers less than 9 here? All the numbers are less than 9. So my event of getting less than 9 equal to 8. Why? Because all the 8 numbers in this spinning mission already less than 8. So I have total 8 numbers. So my event of getting less than 9 equal to 8. So now I got the sample space or total possibilities as well as event of the every question. Now simply I need to substitute this data in the formula. So the probability of point at 8 equal to, what is the event of 8? 1. The total possibility is 8. So we'll got the 1 by 8. Next come to probability to point out at odd number. How many odd numbers I have? 4. So total possibility is 8. By simplifying, we'll get the 1 by 2. Then come to third problem. Probability point out at number greater than 2. How many numbers I have greater than 2? 3, 4, 5, 6, 7, 8. Total 6 numbers I have greater than 2. So my event is 6. So and sample space is 8. By substituting, we'll get 6 by 8, which is nothing but 3 by 4. Then come to the fourth question. The probability to point out at number less than 9. See here, there is an interesting fact you need to find. The probability to find out number less than 9. See here, all the numbers, all these numbers less than 9. So my event equal to 8. Why? Because I have 8 numbers which are less than 9. So my event equal to 8. The total possible is also 8. So by simplifying, we'll get the probability is 1. The probability 1 means there is a 100% chance of happening. See, here the condition is the number less than 9. See here, all these numbers are less than 9. So there is a 100% chance. So whenever it stops, it must be stop on the number which is less than 9. So there is a 100% chance of getting. Read the problem number 5. One card is drawn from well shuffled deck of 52 cards. Find the probability of getting king of the red color and the probability of getting face card and probability of getting red face card and the probability of getting jack of the hearts. Before going to solve this problem, we need to know some points regarding the deck of cards. We'll discuss one by one. Total cards in the deck of cards is 52. These 52 cards are in two colors. Half of them are black color and half of them are red color. So the black color cards are again two types. They are spades and clubs. Red color cards are again two types, diamonds and hearts. See here, heart, diamond, club. This is the symbol of the cards. So we have 52 cards. These 52 cards are in two color. Half of them are red, half of them are black. So these black cards are spades and clubs, red cards are diamonds and hearts. Again, these spades are 13, clubs are 13, diamonds are 13, hearts are 13 cards. Again, within these 13 cards, I have first number or number 1 named card called as a ace. Ace. Spade have one ace, club has one ace, diamond also have one ace, heart also one ace. And the numbered cards are 10. Total 10 numbered cards. 1, 2, 3, 4 and so on up to 10. So spade also have 10 numbered cards, club also have 10 numbered cards, diamond also have 10 numbered cards, heart also have 10 numbered cards. So along with the number cards, there is 3 face cards, which is nothing but JQK. JQK are called face cards. Spades also have 3 face cards, clubs also 3 face cards, diamond 3 face cards, heart also 3 face cards. Total we have 12 face cards. J means jug, Q means queen, K means king. Total I have 4 jacks, 4 queens, 4 kings, 4 aces. So we read the problem. Now we need to find the total possibilities and the favorable outcome. Then we need to substitute in the formula. Okay. See, we need to find event of king of red color. We know that total red color cards, how many red color cards I have? I have total 26 red color cards. But here in the problem number 1, he is asking king of red color. So I have total 26 red cards. In that I have 2 kings only. One is heart king and diamond king. So I have one diamond king, one heart king. So total I have 2 kings. So event of getting red king equal to 2. Okay. Then come to the event of getting a face card. How many face cards I have? I have total 12 face cards. So the event of face card equal to 12. Then come to the problem number 3. Red face cards. What is the event of red face card? See, I have 26 red cards. How many face cards I have? 3 into 2, 6. Total 6 face cards. Why? Because I have 3 face cards in the heart as well as 3 face cards in the diamond. So total 6 face cards. So we got the event of third question also. Then come to the event of the spade. How many spades I have? I have total 13 spades in the 52 cards. So event of spade equal to 13. So we need to find the event of jack of heart. See, first of all, we have 13 hearts. In the 13 hearts, how many jacks I have? Only one jack. So the event of jack heart is 1. So event of spade is 13. Why? Because I have 13 spades. Then come to the 6th one, the queen of diamond. We have 13 diamonds. In the 13 diamonds, I have only one queen. So the event of queen of diamonds equal to 1. So in this manner, we need to find out the event of question which he is asking. To solve any problem in the deck of cards, we need to always remember the how many cards are there, how many types of cards are there, how many face cards are there, how many red cards are there, how many queens are there, how many kings are there, how many face cards are there. We need to remember always. Then only we are able to solve the problem. In that 52 cards, if I take out one card at a time, how many times I can able to take out? Total 52 times. Why? Because I am taking out one card at a time. So total I can take out 52 times. So my total possibilities are 52. So the total possibilities are 52. Now we got the total possibilities as well as event of the each question. What to do now? We need to substitute in the formula of the probability. So the probability of getting the red color, the event of red king is 2, the total possibility is 52. By simplifying, we get 1 by 26. The probability of getting the face card, the event of face card is 12, the total possibility is 52. So 12 by 52, by simplifying, we get 3 by 13. The probability of getting the red face card, we know that the event of getting the red face card is 6. So by simplifying 6 by 52, we got the 3 by 26. The probability of getting the jack of heart, we know that event of jack of heart is 1. So the total possibility is 52. By substituting, we will get 1 by 52. Okay. Then come to probability of getting the spade. I have total 13 spades. So the event of spades equal to 13. The total possibility is 52. By substituting, we will get 1 by 4. The probability of getting the queen of diamonds. We know that event of queen of diamonds is 1. The total possibility is 52. The probability we got 1 by 52. So a lot of 20 bulbs contain 4 defective ones. From this, one bulb is removed which is not defective and is not replaced. Now, one bulb is drawn at random from the rest. What is the probability that this bulb is not a defective? So, I have total 20 bulbs. In the 20 bulbs, 4 are defective. Means 16 are good bulbs and 4 are defective. So, total 20 bulbs. As per the data given in the problem, one non-defective bulb removed, then available bulbs are 15 good bulbs plus 4 defective ones. See, one good bulb is removed, then I have remaining 15 good bulbs and 4 defective ones. What is the probability that this bulb is not a defective? How many not a defective means the good bulb. So how many good bulbs I have? 15 good bulbs. I have 20 bulbs, 4 are defective and 16 are good ones. As per the given data, I removed one good bulb, then I will have remaining 15 good bulbs as well as 4 defective bulbs. Total 19 bulbs. Why? Because I have already removed one good bulb. Then I have only 15 good bulbs and 4 defective. Total 19 bulbs I have. Here we need to find the probability of not a defective one. Not a defective one means it's a good bulb. So how many possibilities of good bulbs I have? 15. Total possibilities 19. So it will become 15 by 19. Question number 7. A die is thrown twice. What is the probability that 5 will not come up either time? 5 will come up at least once. I have a dice. I have thrown this dice 2 times. How many total possibilities I have? Total 6 power n, which is nothing but 6 square. Total 36 possibilities I have when I throw a dice 2 times. 36 possibilities are total possibilities or sample space. I got the sample space or total possibilities now. Then we need to find the probability that 5 will not come up either time and the probability 5 will come up at least once. First of all, we need to find the event of that 5 will not come either time. See, observe this pattern. Every possibility have 2 numbers. Every possibility have 2 numbers. We need to find the event of 5 will not come either time, which means we need to find the results which doesn't have at least a 1 5. So it doesn't have any 5 at first place or it doesn't have any 5 at second place. So I need to remove all the possibilities which included 5 either at first place or at second place. See here, 1 5, 2 5, 3 5, 4 5, 5 5, 6 5. All these results have included the 5. So I need to remove this. Why? Because as per the condition, 5 will not come up either time. So 5 should not be there in the possibilities. So I need to remove all the 6. Then come to 5 6, 5 4, 5 3, 5 2, 5 1. See, in these numbers also or in these results also 5 is included. So I need to remove this also. Total this 6 1, this 5 1. These 25 results are event for 5 will not come either time. Then come to, we need to find the event for 5 will come up at least once. So we need to find the entries or items which has 5 at least once. Total this 6 items and this 5 items has at least 1 5. So I can consider this as the event. Total this 6 and this 5. Total 6 plus 5, 11. Now I need to find the probability that 5 will not come up either time. So we know that event of 5 will not come either time is 25. Event for 5 will come at least once is 11. By substituting, we will get 25 by 36 and 11 by 36. Question number 8. A box contains 90 papers which are numbered from 1 to 90. If one paper is drawn at random from the box, find the probability that it bears a 2-digit number and probability of perfect square number and the probability of number divisible by 5. Total 3 questions asked in this question. I have 90 papers. Each paper written as 1, 2, 3, 4 and so on up to 90. I shuffled 90 papers and kept in the box. If I pick out one paper at a time, how many times I can able to pick out? Total 90 times. So here my total possibilities are 90. Then we need to find the event of 2-digit number, event of perfect square, event of number divisible by 5. First we will find the event of 2-digit number. See here, from 1 to 90, how many 2-digit numbers I have? We need to draw them separately. For example, from 1 to 90, my first 2-digit number will be 10, later 11, 12 and so on up to 90. Why? Because 90 is my last 2-digit number as per the given problem. So 10, 11, 12 and so on up to 90 are my 2-digit numbers. Okay, how many 2-digit numbers? If I calculate manually from 1 to 90, I will get 81 2-digit numbers from 1 to 90. I have total 81 2-digit numbers. So the event for getting 2-digit number is 81. Okay. Then come to the event of perfect square number. From 1 to 90, I need to find out the perfect square numbers. Let's say, for example, 1 is the perfect square number, 2 also perfect square, 3 also perfect square, 16 also perfect square. In this manner, I got total 9 perfect square numbers between the 1 to 90. So these are the numbers which are perfect squares from 1 to 90. So how many such numbers I have? 9. So the event of perfect square number equal to 9. Then come to third question. I need to find the event of number divisible by the 5. From 1 to 90, 5, 10, 15, 20, 25 and so on up to 90. These numbers are divisible by 5. So we need to find this, how many numbers are possible which are divisible by 5. So using the arithmetic progression formulas, we can find out how many numbers which are divisible by 5. So Tn is nothing but nth term. Tn equal to a plus n minus 1 into d. Here a equal to first term, n is the d is the common difference. So here Tn equal to at the nth term, which is nothing but 90, which is equal to 5 plus n minus 1 into d. See here the common difference. See here 10 minus 5, 5, 15 minus 10, 5, 20 minus 15, 5. So this is the common difference, which is nothing but d. Here the common difference is 5. The first term a is nothing but 5. So by substituting, we will get n minus 1 equal to 85 by 5, which is nothing but n equal to 18, which means from 1 to 90, I have 18 numbers which are divisible by 5. So by event of number which is divisible by 5 in the given question is 18. Why? Because I have 18 such numbers which are divisible by 5. So my event is here 18. By substituting the sample space and the event, we will get the probability. The probability that 2-digit number, we know that 81 2-digit number, the total possibilities are 90. By simplifying 81 by 90, which is nothing but 9 by 10. The second one is the probability of perfect square. We know that total perfect square, how many perfect squares I have? I have total 9 perfect square. So which is nothing but 9 by 90. By simplifying, we'll get the 1 by 10. Then come to the third one, the probability of number divisible by 5. How many numbers I have which are divisible by 5? Total 18 numbers. So my event is became 18 here. So 18 by 90, which is nothing but 1 by 5. In this manner, we have to solve the problems. Which are the following probability of most unlikely happening of event? In previous class, we have already learned the probability always lies between 0 to 1. If the probability near to 0, this is unlikely to happen. If the probability near to 1, this is most likely to happen, which means more the possibility to be happen. If near to 0, more possibility to not happen. See, here the problem is, which are the following probability of most unlikely happening? Here is asking the most unlikely happening. So we need to find out the probability which is near to 0. See here, this is the near to 0, which is nothing but the smallest value among all the options. So this is the option. Why? Because this is the lowest probability. So which means this is most unlikely happening. What is the probability of getting red face card when we draw a card from the deck of cards? We know that we have total 52 cards in the deck of cards. So that's my total possibilities. We need to find the probability of getting the red face cards. So we need to find the event first. We need to find event of getting red face cards. How many red face cards I have? I need to find out now. I have 3 face cards from the heart, 3 face cards from the diamonds. Total face cards I have in the red color, 3 plus 3, total 6 face cards. In the deck of cards, I have total 6 face cards, 3 face cards from the diamonds, 3 face cards from the hearts. Total 6 face cards I have. So my event of getting red face cards is equal to 6. By substituting the probability formula, we'll get 6 by 52, which is nothing but 3 by 26. Probability of non-leap year contain 53 Sundays. So we know that non-leap year is nothing but which has 365 days. If it is a leap year, it will become 366 days. So we need to find in these 365 days, how many weeks are there? Simply by dividing this 365 by 7, we'll got the number of weeks. So 360 by 7, which is nothing but, by solving, we'll get 52 weeks and 1 extra day. So in these 365 days, we have 52 weeks and 1 extra remaining day. So 52 weeks means we have 52 Sundays, we have 52 Mondays, 52 Tuesdays. In this manner, all the days of weeks have 52 and 1 works. So 1 extra day. This 1 extra day can be Sunday, it can be Monday, it can be Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So it can be any day from Sunday to Saturday. So my total possibilities are 7. Why? Because this extra day can be any number from Sunday to Saturday. So my total possibilities are 7. Now we need to find the event of Sunday. In this total possibilities, how many Sundays I have? Only 1 Sunday. I have only 1 Sunday in the total possibilities. So my event of Sunday equal to 1. So by simply substituting the probability formula, the event is 1 and the total possibilities are 7, which is nothing but the probability. So probability of getting 53rd Sunday or 53 Sundays is 1 by 7. Question number 11. Probability of getting a bad egg in a lot of 400 eggs is 0.35. Then the number of bad eggs in a lot. A person has 400 eggs. His probability of getting a bad egg is 0.35. Then how many bad eggs are there in that 400 good eggs? That's the question. We know that the probability equal to event by sample space. So as per the data, the probability equal to 0.35 equal to event by total possibilities we need to find. So here the event or favorable outcome is bad eggs. Why? Because by the end we need to find the bad eggs. So here my event will become bad eggs and the total possibilities are 400. Why? Because I am taking out 1 egg at a time. How many times I can able to take out? 400 times. So my total possibilities are total x will become 400. So 0.35 equal to x by 400. So I'm imagining bad x as x. By simplifying, we'll get x equal to 140. So if 400 eggs I have 0.35 probability to get a bad egg, then I have 140 bad eggs. So in this way, we have to find. Simply what we are doing here, just we are substituting all the values given in the question in the probability formula. By solving, we will get the answer. Number 12. Someone asked to take numbers from 1 to 20. One number drawn at randomly. What is the probability of getting prime number? See here. I have certain numbers which are 1 to 20. Total 20 numbers I have. If I take out one number at a time, how many times I can able to take out? Total 20 times. So my total possibilities are 20 here.